So, hello. I think we'll wait for a few more minutes. It's still another 4 minutes left.
Hey, Shiva.
Hey, how are you?
Good.
All right, good. So, what I was thinking for this session is slightly different. Is instead of just me sharing my screen, which is what I was doing last time, I was thinking that we could have somebody else share and code instead, because that is essentially what this is all about. Somebody else also programming. So we have two so far. I guess there's still a few more minutes. Let's wait for some other people to join.
Yeah.
So since we are waiting, does anyone have any initial comments to get started?
Not exactly. I just trying the example. It's just one question. Where did you inform that we are going to work on this specific problem? Because I don't see it anywhere.
Actually,
This
it
is
would have
highly
been
visible.
on the very first LinkedIn. I think this would have been on last Thursday's post, LinkedIn post.
Okay. Because I only saw it in the Join Howdy page, and so I think I can see it.
Yeah.
Okay, so it's in LinkedIn. Okay, yeah. I don't think I paid sufficient attention to what was there in LinkedIn. So I was just wondering if I missed something obvious in the interface, which is fine. Just puts the problem.
The only other update is I have added a link to a Google form on the Howdy description, on the group description. So what I do is, if you can add your email to that, then I can send you an invitation to a Google group.
Okay. No. Okay. Perfect. No, it's just okay. I will do that. It's just maybe perhaps this could be a feedback to Darius because it could be just a small announcement, like in Moodle, where you can just have a small announcement or something like that. So on the Howdy page itself, so that if there is some updates, not necessarily spamming with a lot of data. If it is just a basic thing, okay, this is what we plan to do. It probably could be also you can update it, a few days before if there is a need for it.
Yeah, I guess we could. We could do that.
Because having multiple places to do it. You organize it because you are doing it, but from the tool perspective, it could be just that there is a place where you can do everything and you don't have to go elsewhere to find information.
Okay, so it's almost 6.
Yeah.
So I guess we can wait. We can get started. As people join, let them join. So like I said, I would like somebody else to start sharing and coding. So any one of you would be nice. It's like, because this is after all for the rest. Yeah, and this can be a round robin also. So you can share once, share again, no problem.
Okay, I will do it because probably you're going to be mad because this is in Windows and it is in PyCharm, but anyway.
Okay, sure.
Anyway, so I will start. Okay, okay. This is there's some problem with it's not allowing me to share the screen, but I'll just try.
Oh.
It says that, I mean, Firefox is just I have logged in through Firefox and it is saying that I said select it. Okay. Okay, it is just asking. Okay, fine. Okay, so can you see my screen?
Yep.
Yeah.
Okay.
Right.
So I'm just trying to. I mean, we were talking about different components.
Mm-hmm.
So I started with compute the triangle number.
Mm-hmm.
Okay, I started with the basic loop,
Mm-hmm.
and also wrote sort of using NumPy
Yep.
functions, using the NumPy sum.
Mm-hmm.
And I mean, I don't think I'm going to see a big difference in
Okay, so let's
how
go
this is
through.
going to.
Sure, no problem. So let's look. You have compute triangle number, for which you have some number, which is the index. Second is next thing is, when you import packages, try not to import them within functions, because then it's scoped to the function, and then you're like importing it again and again. So it's best always to put your imports at the top of your file.
Okay. So this scope issue is something I probably am not very comfortable with, I think. So this import, when you do it at the top of the file, is this scope valid even if it goes into functions that you call from the file, even if that the function is not within the same file?
No. Then in that case, you would have to call it in that file, or you would have to pass it.
Okay.
As an argument. But usually when you're writing modules with Python, you would like to keep every module as sort of self-contained. So therefore, if there is a module which, let's say, is doing all factorization, let's say it has 20 methods of factorization, then you are using certain number of let's say packages. It could be math, it could be NumPy, in which case it is sensible just to import all those methods or all those packages into each file, so that you have each file as self-contained. That is usually how it is recommended.
Okay.
Alright, so then we are into return NumPy np sum. Okay, yeah, so that is, so just as, I mean, since there's one other person, just one little, you can see there's little discussion is, in NumPy, if you use the np.array, then you can pass a Python list to it. So for example, if I say np.array, I can put a list 1, 2, 3, 4. And this list 1, 2, 3, 4 in square brackets is now cast as a NumPy array. Okay. Now you are specifying a range idx plus 1. So a range id, or rather range idx plus 1 essentially means range from 0 to that number itself, because range always stops 1 before that. So that's why range 1, number plus 1. So this gives you from 0 all the way up to that number. Now when you cast this range object, range is an object itself, it's an iterable. Now you need, technically speaking, you should pass a list, but even if you pass an iterable like a range object, you can still cast it to a NumPy array, and that's what we've done. np.array, you've cast an iterable to a NumPy array. Now later on, once you've done NumPy array, you will see then you are using np.sum on it. Now this is perfectly okay, but if you have an array, you can just use the sum method on it. So even this is not necessary. So You just say np.array a range and in the end dot sum with empty parentheses. That's good enough. So like basically like a NumPy, like in Python, everything is an object. Even a string, an integer, a decimal, anything is an object. So an object has attributes and methods. So with NumPy, you have methods like sum and several others. So these are the recommended ways to do it.
Okay.
So this is one. So now compute factors. So I guess we can keep going.
Yeah, compute factors. Okay, this is okay. Just a second. I will just do. Yeah. Just.
Yeah.
So, so the compute factors. What I did was I kind of okay. Let me just put it together. Yeah. So what I did was I went through a range from 1 to the square root of that number. That is the tnum. Again, maybe this is not required. I think.
Yeah.
Now, yeah. And then I check if that number is divisible by. I mean, I check whether the input is divisible by the range, the specific number. If it is so, append it into the factors. Now, since this is like I'm only checking up to square root, it's probably not. I mean, this is something I'm trying. It's not necessarily the best way, but so what I'm doing is if it's if the square root exists for the given number, then so the idea is you probably can forget this. So what I'm trying to do here is that once we have found all the factors until the square root of that number, you don't have to check whether it is divisible, but you just see you just pick the value. I mean, like if it's like, for instance, I'll give you an example here.
Yeah, I'll just like clarify just in case you know. For example, any number is divisible by 1 in itself. Now, despite the number being divisible by itself, the other biggest factor of any number is the square root. So you will never find the only number which is a factor of that number, or rather which is a factor but is greater than the square root is the number itself. So if you stop at 2, right, usually the normal algorithm is you stop at number divided by 2. So let's say we have a number like 25. You can stop at 25 divided by 2, which is around 12. You can stop at that. But it's important to know that you need not go up to 12. You can go to the square root of the number itself. Because if you see, the number will not, you will not find, how do I say it? You cannot divide the number by anything larger than the square root itself. So for example, actually I should probably take an even number. Let's take 36. Okay, so we have 36. The square root of 36 is 6, right? So since the square root of 36 is 6, you can choose to go up till 6, or you can go up till half of that, is the 18. Now if you go up to half of that, which is 18, you are iterating from 1 to 18 and checking if they are divisible. But if you stop at 6, you will find that the number 18 is also included. So in that case, the only thing you need to do in factors is the trick is you need to make sure that the remainder, when you do a division, the actual equivalent is also included in your factor. That is one thing you have to remember. So for example, if you stop at 6, then you must make sure that 2 into 18 is also included. That's the only other little catch.
Yeah.
Okay.
Yeah.
Yeah, that's it.
Exactly. Yeah. That's exactly what I'm trying to do, but I was not probably. I should have done it within the same loop, I would say.
Yeah. So
I was just trying to see if I can split it up and do it separately. But yeah, you're right. I in the same loop where I check whether the remainder is 0, I will have to pick up the quotient. If the remainder is 0, then I'll have to also add the quotient.
yeah. So basically, you just have to put. You can put an if loop. You can do it right now. All you have to do is if tnum percentage x is equal to 0, which means the number is divisible. Again, you do not have to specify equal to 0. You can specify if not tnum percentage x. That is, if you say, basically, if you remove the equal to 0, that means you are checking if tnum percentage x is not 0. Is something like what you call is any number other than 0. If you say not of that, actually you have to write not. It's actual letters, not. In Python, they've put not. Actually, all small.
How does it go?
All small, not.
Okay.
See, now it becomes a reserved keyword. So first you have to add the number. Then you can check if you can add to that if tnum divided by x is greater than the square root I mean, you probably have to write np dot square root, then add factors, comma, append that this thing itself. So you can, I mean, it might be easier to actually give another number, like for example, you can say x or greater division or whatever is equal to tnum divided by x.
Okay, just a second. So
basically, since you've done
you want to give this one a separate name.
Yeah, so you can just after
makes sense. Yes.
So just say why, because it's appearing several places.
Just one question here. When I do this, when I do tnum divided by x, it converts it into float, right? So I have to do
divide by. Do a double dash.
So I'll say divide. Okay.
Yeah.
Okay.
So this is just that one check, just to make sure that if the actual quotient or the division is greater than the square root, you're not missing that out.
Yeah.
Okay, cool.
Yeah.
So, okay, now this is it. Return factors. Okay.
Okay, just a second.
I mean, I suppose Nikhil, you're also welcome to add anything you want. It does not have to be just me. It's a discussion group.
Actually, I'm very new to the Python language.
No, this is how you learn. That's why I would like all of you to start sharing. So, I mean, you're welcome to share next, because this is how you learn.
Yeah.
So, we have a significant...
I was trying out very basic things. Like I was browsing through some Python YouTube videos and I was trying to do something. But I have not done anything in this particular logic which we have decided to do.
No, that's the thing. I would like to take... Actually, this is just because I had to pick something in the beginning. But soon I would like to start taking up challenges from Kaggle or something like that. So then we can just pick challenges, we can solve it iteratively, whatever we want. That's it. So anyway, so no problem. Just keep going.
What is not happened? Yes. Yeah. So PyCharm is a bit not happy if there are no sufficient spaces between them.
I see.
Yeah.
Okay. So now if we keep going.
Okay, so the next step would be to compute, look at the size of them, right? And then say if it has reached 500 or not.
Yeah.
So So this this one should just, so the next to find triangle number of factors should essentially call this compute factors. No, and
So
then
what you need is an infinite loop to begin with, because you are stopping when the number of factors is greater than this number minimum factor, greater than or equal to.
yes.
So first what we can do is we can write our logic and then embed that inside an infinite loop. So what I would say is, let us suppose that you are starting with a number. In this case, usually you always start at, I would say you're starting with 1, right? And you go expand on the loop. So,
Okay.
so if you want to expand, first we can initialize our number. So we can say, give it any name that you want. Let's say, for example, initial guess or whatever, initial number, init number. So we can start at 1 because it could be anything, right?
Yeah.
So now once we have this, you are now going to find the triangle number for this. So this is our initial index, right? So you can call that
This compute triangle.
and you can assign it to something which is initial triangle number or whatever. I mean, you choose your, only thing is, whenever you name variables in Python code, try to actually describe what the variable does. Unless it is a loop, try not to use like single syllables like x and I and things like that. For a loop it's okay, because it's very simple. But when you're actually writing logical code, if you look at it later, you should know what that variable does. Otherwise x, a, b don't really help you. Okay, so this is your triangle number. Now the next thing which you have to do is this triangle number, triangle factors. So you can now call that. So these are your triangle factors. Now what we have to do is, you have to find out the length of your triangle factors. So what we have to do is, we have to check if the length of triangle factors is greater than the argument which is passed. Now what do we do? So the question here is, now we need to bring in our infinite loop, right? So here, before you start this loop, you can now say while true. That is an easy way to start an infinite loop. No, this is after init num, because that is where the initialization takes place.
Yeah.
And true has to be T capital.
Okay.
So here again in Python, you don't have to put a parenthesis around the Boolean logic. So it's best that you leave a space. That is like usually easiest to understand. So now, if your triangle numbers is greater than or equal to the minimum number of factors, you are done, which means you can break out of the loop. So you can put a break statement here. The break statement will break out of the loop, of the immediately enclosing loop, whichever loop it is. It could be a while loop, it could be a for loop, it could be anything. It will then go to the statement after that immediately enclosing loop. So you could have embedded loops. The break will leave the immediate loop around that. Not the most inside loop, but wherever you are enclosing, wherever you are putting the break statement. Break means break the loop that I am currently working on. That's all. So now that we are here, if this is not satisfied, what do? We have to go to the next triangle number.
So I would say init num plus equal to 1.
Yep. Basically, if you have not found the required number of minimum factors, you have to increment and go to the next one. Keep searching. So now that we are here, what else do we do?
Now we have to return something.
Exactly.
Wow.
So once you break, you can return the length of the triangle factors, latest, whatever you found.
Yeah. Okay. Yeah. But yeah. Okay. But this triangle factors length is what we anyway know, right? It will be the minimum factors value.
Oh yeah. So you will have to then return init number.
Yeah. Exactly.
So let me go. I forgot what it is. Let me go and check out in Project Euler.
Can I just ask a quick question?
Oh, go ahead.
Yeah, no, I was just wondering, does Mikhail have any questions, or are you following along? Does this make sense, or do you have any thoughts about what's taking place?
I mean, in what sense?
No, I'm just asking. How do you pronounce his name? Nikhil? Is it
Nikhil, yeah.
Nikhil. No, I was just curious if you had any thoughts about.
Actually, I am very new to this thing, so I am trying to follow what Krishnan is trying to do.
Okay. Does it make sense though, or are you?
I'm following. But if I'm having any doubt, I will surely ask.
Okay.
Okay. So now a question: if you go to Project Euler page and read the definition, you'll see that it says that the seventh triangle number is 28, right? So now 28 is the first triangle number to have over 5 divisors, sorry, which is the first triangle number to have over 500 divisors. So now we need the triangle number and not the index. So we cannot return init num, we have to return triangle num. You see? Look at the Project Euler description page.
Yeah, I'm just looking at it. Yeah. Okay. Yeah. It should be the. So we should rather send back.
Triangle num. Basically, it is the triangle number that you've computed.
Okay. Yeah.
Okay. So what we can do, we can now test it out. We can test it out by trying to get 7, because they have already given us that the 7th triangle number is 28 and that has over 5 divisors.
Just a second. I'm just yeah. Okay, so I have the terminal below, so I can run. Okay, I will run it for 7, right?
Yeah, so you just print like the last one.
Yeah.
Actually, you can just comment them, that's okay. Yeah.
Yeah.
So here, when you say find triangle numbers, you are asking for which is the triangle number which gives us 7, but we want 5, because if you look at this one, you see that 28 is the first triangle number to have over 5 divisors. So if you put 5, we should get back 28. So let's run this and check.
Yeah.
And we got it.
28.
So now let's try out a simpler one. Let's try 4. We should get 6. And we got 6.
Yeah.
So I think we are almost done. What else can we do? Not much. So let us now have a little discussion about the code, right? Because there's always other ways to write the code. Now let's go and try to think about ways in which we can improve this. So first thing is, let's look at this. Let's look at the main code. What are we trying to do? The main block, we are starting at 1 and we are going all the, actually you got to go a little up. The main block is up. Yeah. So we are starting.
Fine.
So we are starting at 1 and we are incrementing by 1 each time and going and checking the triangle number for that index, right? So is the first triangle, first triangle number, second triangle number, so on and so forth. Now, first thing we are doing is, for that index we are computing the triangle number, right? So let's go and check out what we can do with compute triangle number. So we go to that function. So now, do you see any way we can improve this?
There is a single line of code.
The single line, actually that's the thing. Now, as a data scientist, the first thing you must always wonder is, index, if it is 5, then it's not a problem. What if index is 5 billion?
Okay.
That is the first thing must always, and you are in data science, you must think in millions and billions. Because that's what will come and when you get into data science. Now, when you get into data science and you have, if I give you a number like 5 billion, right? And you have to count from 0 to 5 billion, then that's okay. That's just how it is. But let us suppose you're doing it again and again. So let's say you have 5 billion entries and you have to calculate the triangle number 5 billion times. Now think about what will happen if you do this. You are starting from 0 each time. So it's 1, 2, 3, 4, 500, 1000, 10,000, 100,000, 1 million, all the way up to 5 each time. Now the question is, do you know if you may need to do this? You might need to do this, you may not need to do this. Again, it's best if your code is as general as possible, right? So one concept I'd like to introduce first is it possible that you add another argument? So for example, you say, now this is the number that I currently have, right? And this is the number which was there before. So if I've calculated it, no need to calculate again. So I'll tell you that this is the sum which I have. This is the next number. You give me the remaining. Amount. Right? This way, you can do it both ways. One, if nothing is given, in which case you have to calculate the triangle number, you sum up the entire thing. If on the other hand, you are given another argument, that is, you are saying that this is the previous number and this is the previous sum. In that case, we just use the previous values.
Yeah.
So what this means is, with the current index, we need 2 more arguments, right? The previous index and the previous sum. Now, it does not have to be that it could be one only. Like I said, again, try to think as general as possible. It could be a number that is, for example, the previous number could have been 5. Now we are calculating 10. Right? So then what do? You are taking the sum for 5. You are then taking the range of objects between the previous and the current, and you're adding the sum to the other. Right? Now, please feel free to ask any questions.
Yeah. For me, I think I'm clear. I'm just. This is just a comment because it's nothing to do with a specific thing, but maybe perhaps you should probably take the control, and if you have a small whiteboard or something, you should explain it, because I mean, I'm just following what you say based on what my assumptions are also. The assumptions I also have. It probably could be difficult to follow if you are just explaining it. So for me it's fine, but maybe Nikhil has to.
Yeah, actually, I'm having lots of doubts because I'm very new to this programming and also for Python also. So if you could just start by how do we what the approach we take while we see any problem statement to write a code. So if you start by those things and then you generalize how each and every step, then it will be very helpful for me for this stage. And maybe 1 or 2 sessions, I will be able to catch up with your speed as well.
Okay, sure, we can do that. So you can stop sharing and share mine.
Yeah.
Alright, so this is where we had stopped off the previous case. I had not continued here. So I'm just going to say import numpy as np. And here, let me just comment this code and write this code, that is return np dot array, and here let me put range index num plus 1, and here I'll put the sum. So let's come all the way down here and let me just run this so that at least let's check if we, because let me check if I have numpy. Okay, I don't have a console open yet, so let me just go.
Just a question on this, what we were doing. You said that this I can either use, I had done np.sum and I calculated the sum, and we are now using the modules that are available for this specific object, that is np.array object. So is it one is faster than the other or something like that?
Technically it is possible. The reason why it's possible is because the way NumPy creates objects. So for example, when NumPy creates an array, the way it defines the array in terms of data, of like how the data is populated in memory, that is what makes a difference. So when you use the sum method, which is a part of the object, the result is you are automatically assuming, like for example, NumPy assumes that this is an array which you are summing up. So from an algorithm point of view, this is a specialized method as opposed to np.sum. np.sum is a general method. So np.sum being a more general method may use an algorithm which is slightly more time consuming.
Yeah, okay, I see.
Of course, these only really make a difference when you have very huge numbers.
Yeah.
Alright, so we have 28. So let's come all the way here. Now, let me write this down. Okay, I can remove this, is it okay? Because this doesn't really serve much purpose now. Yeah. So, what I wanted to write is this. If we need to calculate a triangle number for 5 billion, right? We sum from 0 to 5 billion.
Yeah.
Right? Now, if we need to sum continuously for 5 billion rows, right, of data, what that means is we need triangle numbers for 100, 500, 100,000 and 5 million and 5 billion, let's say. And these are just like actual discrete values. We need everything. Okay. So now what happens, if this is what happens, we are calculating every time the sum from 0 to the number. Right? We are repeating this every time. So computation is repeated. Okay, we are doing the same thing again and again and again. Right? Now, the good thing is, since it's a computer, at least it doesn't get tired. Right? So because as a human being, you would get fed up. But as a computer, even though it doesn't get tired, it takes time to do it. Now, as and how your number becomes greater, this time taken matters. So for example, I'll give you an example. Once I attended a talk by somebody who was a programmer for an investment bank. And he said that even though computers are getting faster and faster, you have all investment banks coming up with algorithms to trade. So even if your algorithm can return within 1 second, if your competitor can return within half a second, you lose money and he makes money. Even if you're a few seconds too late, you are out of the market. You pretty much will never make any money. So this is how fast you have to compute if you really want to stay in the business. So when you repeat computations, you spend time. That time can be very costly later. So what we do is, when we are repeating, we use previous values. Alright? So this is what we have to do. So what that means is this. Supposing we calculated triangle number 7, for 7, index 7, okay, is equal to 28. Now we want to calculate triangle number for 8. What do we do?
28 plus.
Exactly. We need 28 plus 8 is equal to 36, right? So we need to take current index, previous index, previous sum, or previous triangle number, right? Let's call it previous triangle number because it is actually a triangle number, right? Now, this is one case. But again, to make it more general, supposing I want to calculate triangle number 12. Okay. Now what do? I will
Then
take.
we have already calculated for 8. Then adding till 36 plus 9, 10, 11, 12.
Exactly. So let's write that in a programmatic sense. We have calculated for 36. We need to calculate for some range. Can you tell me?
Anything greater than 36.
No. I'm saying we need, we want to calculate the remaining sum. So can you fill this for me? Basically 9 to 12.
Okay, 9 to 12. Okay, yeah.
12 plus 1, remember. Okay, because remember,
Because it will
range.
not reach 12.
Exactly. Range will never reach the last number. It will always stop before that. Okay. So this is what we have to do.
And what if we are computing for a lower number than the earlier calculation?
Yes.
Like now we have calculated for 7, but in next calculation we are trying to do for maybe 3 or 4.
Very good.
In that case.
Yeah, that's also the very good number question. So what we have to do in that case is, supposing I say calculate triangle number for 3, right? Now, how will you do this? We calculate, let's say I start at 36, okay? 36, what will I do? Can you tell me?
because the previously we have calculated for 8, you're saying, and for the next iteration we are calculating for 3. So we have previous in history we have 36. So
See, remember, we don't have everything. We're not storing it. If you store everything, it becomes too much data. So you don't want to store too much.
Maybe
also.
we can subtract
Exactly.
the remaining.
Yeah. So, minus sum. Now what will you do?
From 4 to 12. 12 plus 1.
Actually, here we should put 8 because we are doing 36.
Yeah, yes, sir.
Right? So, this is okay?
Yeah. There is also range can also take the step size, right?
Yeah, range can take the subsets.
Yeah. So you can also do 7 to 3 with a minus 1.
I suppose you could, but since you only want the sum, it doesn't really matter which direction you're going.
Yeah. It doesn't matter. I'm just.
Yeah, you could do that. So like you're saying, you could do 7 to 3, comma, minus 1. This is possible.
Yeah. This is possible. Yeah. That's so. Okay.
So there's only one other thing I can do, but before I would like one of you to code it. But what I would like to do is I would like to show you one little thing. How do you know how to add an optional argument in Python?
You give the value.
Exactly.
The value
So you can do previous num, right? And you can give it a value. So you can say minus 1. Right? So this is an indication that if the previous number is less than 0, we know that we don't have to do anything. Right? This is a regular sum.
So what is this minus 1? Previous number is equal to minus 1.
It means that this is the default value of your argument. So if you don't pass this argument, automatically this argument will be given this value. And I will show you how to do it.
Minus 1.
Yeah. So like for example, previous sum is equal to minus 1. So now let me come over here and print these two. Print previous num, print previous sum. Alright. Now what I'm going to do is I'm going to call the same thing again. So right, say calculate 7 number. Right? You see what has happened? I have not specified the two arguments. I am calling it exactly the same, just with one. Right? Let me just give some space here. I am calling it only with 7. So which means if you have not given these arguments, it takes the default value. And if you see here, these are the default values.
Okay.
Now I can change this and make this 7, 5. Now I'm giving one more value. So now it takes the first argument, but the second argument is still negative, minus 1. And in this way, I can now give all of them. So I can say 100. Oh, I didn't save it, I think. Yeah, I didn't save it. Yeah, now all three are coming. So now what you can do, this function is now a little more flexible. You can use it the regular way. You can use it in the other way as well.
But the previous number and previous sum should be saved automatically, no? In this case, means if we are generalizing the code, then when we compute for one value, then in next run it should automatically retain the history values in the other two arguments.
No, I am sorry, I didn't follow. No. What? Okay, I see what you mean. So the idea was what he's saying is that. So what Shiva is saying is using these two extra arguments that are there would be used by the other main function, which is calling this function to pass these arguments. So for instance, the main function will first ask you compute me the sum until 6 numbers.
In this case, main function is compute the triangular numbers.
No. It's the other one. Like, for instance, in this, find the triangular number factors. Yeah. So, in the when we find the triangular number factors, calls, okay, in a loop it calls this value for 6, and then the next time it calls for 7, it sends the previous value that it has computed to 6. So the function that where Shiva has added extra parameters, that doesn't have to remember it. It is not going to remember it.
Okay, no, actually,
it for this particular sense, and then it is the, this function is being called several times. So the one at the top will be the one who will remember it, not this function itself.
okay,
So to ensure that this function is given the previous history values, we add new extra inputs, so that through that inputs the top function can send it.
Okay.
So just to add to that, when a function returns, all the local variables and the arguments are destroyed. So they are temporary only within the function. When the function is called, then the arguments and all local variables come into existence. When the function returns, all these variables are destroyed.
Okay.
So which is why there is no remember. Now there is one way you can kind of bypass this. It's called a generator. So instead of doing a return, you do a yield. When you do a yield, a yield means it gives the number back, but now the function still remains. Right? So you can Google it and check it out. It's called a generator. Look for a Python generator. Okay. Now, even though Python generators like this exist, they are very tricky to actually work with. Because remember, Python, when you have a Python function, when it returns, when you have a return statement, everything is destroyed. It's a clean statement. Now in a generator, it always memory. It is always remembering. Which means its flexibility to be used in different applications is a little limited. So for example, if you know a particular problem and you want to apply it to that, you can use a generator. Right? Generator is very conveniently used, for example, when you want to generate, let's say, prime numbers or Fibonacci numbers or things like that. Now, when you want to find out a series, right? Then it is sometimes very convenient. And when you realize that you are always generating series, then it's very convenient. But if you are calculating something, then it may not be that convenient, because now it will always continue from the previous point. So you may not be able to use it in another application. That's the problem. So it's a little tricky. But if you are interested, Google generator, Python generator.
Okay.
And you just have to use a yield statement. That's it. And also there is another problem with the Python generator is there is a potential for a leak. Because what happens is all memories are retained, all variables are retained in memory. So if you are not careful and you have an array which is increasing or something of that sort, all those arrays are stored in memory because the function has not terminated. When a return is there, function is terminated. A yield does not terminate the function, so which means it can technically blow up your memory. So a generator should be used with caution.
Okay, I think we should complete that previous thing first so that we can...
No, actually what I would like to do is I would like to let maybe you program it, or maybe we program next time. We can just look at another. I want to show you one more aspect of the code. So maybe if you can share again, Krishna, and I'll just tell you what it is. We can just have a look. Because generally in programming, especially in data science, try to save every little bit. Every little computation that you can save.
Yeah.
Right. So now this is your triangle factors. Okay, now that we've done what we can with compute triangle numbers, the next one is compute factors.
Okay.
Right?
Yeah.
Now in compute factors, do you see any potential for change? We are dividing from 1 all the way to our factor, to our square root of the number, right? Now, there's two things which are there. There is no need to divide by 1, you save just one calculation, but we save it because every number is divisible. The second thing is, in this thing there is one little gap. The gap is that every number is divisible by itself as well. Right? Now, that is already taken into account by the quotient, because you're taking the quotient, right? So when the quotient is there, you're dividing by 1 and the number. So if you skip 1 and you add 1 and the number, you are reducing 2 calculations.
Yeah. Yeah.
Okay, so that's one. The second thing which you can do, let's say for example, you have even numbers, you have odd numbers, right? Now, an even number can be divided by an even number or an odd number. An odd number can never be divided by an even number, right? So if you have an odd number, you do not have to check if it is divisible by an even number. That check is not necessary.
Okay.
So if you have a number like 5 billion, you have reduced your divisions by 2.5 billion. That's quite a lot. So what you should do, check if the number is even or odd. If it is even, you have to divide by all numbers. If it is odd, you have to divide starting from 3 in gaps of 2. 3, 5, 7, so on and so forth. You don't have to divide by even numbers.
Okay. Let me describe the compute factor, what I have understood. So if I am making any mistake, you can correct me.
Sure.
So basically what he has done is that he has created a list named as factors. So whatever computation part will be there, it will be appended to that list.
Yeah.
Okay. So for in first for loop for x in range 1 to integer of square root of t num, means he has just created a range from 1 to the square root of the number whose we are calculating the factors.
You're right.
Okay. So the reason is that because you have said that the number will not be divisible greater than its square root.
Yes.
Yeah, for that he has created the range from 1 till the lowest factor, which will be 1 till the square root of the number,
Yeah.
triangle number.
Yes.
Okay, so if not t num percentage x means triangular number divided by x, its remainder.
Reminder.
Yeah, but what is that not t num x?
Now, in Python, this is syntactic, right? For example, the way you can actually write is if tnum percentage equal to 0, right?
Okay.
Then do this, because you are checking if there is no remainder. Now, in Python, when you want to do a check, for example, if you want to check if some condition is true, right? Let's say I want to say a variable c, let's say, is boolean, it can be true or false. If you want to check if c is equal to true, then you do not have to say if c equal to true. You just have to say if c. Similarly, if you want to check if the boolean variable c is false, you do not have to check if c equal to false. You can say if not c.
Okay.
So when you say tnum, if you want to check tnum percentage x is not equal to 0, it means some actual number, then you say tnum if tnum percentage x. So if I say tnum,
so what is the meaning of this statement is if tnum
percentage x,
the remainder of tnum is not does not exist.
what you have to read it like this: the not should always be the last. So first say if tnum percentage x, that means if it is not 0, it means any number which is not 0. You are now taking the not of that. The not of not 0 means it is 0.
Okay. Okay, so tnum percentage x by default it is equated to 0.
Yeah, when you say if tnum percentage x, it means does this number exist? And when you say exist means if it does not exist, it means it's 0. 0 means the number doesn't exist.
Yeah.
Okay.
Okay. So here it is saying that it exists because we have used not here.
No, that's the thing.
So if this statement is satisfied, then factor is appended with that number.
Yeah. Okay. Now again, you have to read it the right way. See, then always when you're reading a Boolean, right, and you see a not, the not should be evaluated at the end.
Yeah.
So if you look at tnum percentage x means, is this number not 0, right?
Okay.
If not tnum percentage x means, if not the number is not 0. So how do you see it? If the number is 0.
If the number is 0.
Exactly. Not. So it's two nots cancelling each other.
Yeah. So then if the statement is satisfied, then the factor in the factors list, that number will be appended.
Right.
Okay. And quotient is equal to, it is integer number divided by the number. Okay. And if quotient is greater than square root of tnum, factors append quotient. So what does this giving us? Because we don't need to check value greater than the square root of the number. No?
The thing is, we don't have to check until then, but remember, if let's say for example, I can give you the example of 36. Take a number 36, the square root is 6, right? Now after 6 you will not find any unique division, right? But let's say I say divide 2, take the number 2 is divisible 36, right? 2 into 18 is 36. Now there are two factors, 2 and 18. We have to add both factors, right? Now, if we had taken 36, the number divided by 2, then we would have reached to 18. But now we are not reaching to 18 because we are stopping at the square root. So, which means we have to check if the division results in a number which is greater than the square root. Because in that case, we should not miss that number also.
Okay. But here we have nowhere we are divided by 2 somewhere.
No, that's the reason. Because see, by doing this, you are saving. Like I said again, if you divide by 2, you have to calculate much more. So let's say you have 100. Alright. If you have 100, divide by 2 means you are checking from 1 to 50. You are checking 50 numbers. If you divide by the square root, you are checking 10 numbers. So huge drop, 50 to 10.
Okay.
But
and that is not yet done. I mean, that we have to do.
Yeah.
Yeah, that's why I'm finding that.
Yeah. What she was explaining is not yet done. We have to do. So what is there here is a way we have not optimized. We are now, what he has explained is how to optimize it, but we will have to do it.
Yeah.
Okay, cool. I think we are almost out of time. So what I would suggest is, let's in the next thing just think about this little bit, 2 things of code which we can do, and I'll be happy to field questions. Then we can think next time, depending on how many people join. I don't know if more people will join or not, but we can keep continuing if you're interested, that is. And otherwise I'll show you how to go on. I think if you're comfortable with this, we can start doing some stuff from Kaggle. So we can go on Kaggle, we can just browse for something and pick. So I can show you how to look at data sets, how to find out what to do, how to browse around, because there are lots and lots of data sets. To be able to even pick a good data set that you can work with, it requires a little bit of filtering. So I can just show you how that is. We can pick something and do some initial, even we can pick several of them. We can pick several and do some initial quick data analysis just to see whether this is interesting enough to look at. And then we'll pick one to keep analyzing.
Yeah. So just one thing, you said you probably are going to go on a vacation. So next week you're around.
Next week I will be around. Next week is, what is it?
Some
22nd. Actually, there might even be one more after that because my vacation will probably be pushed a little. So yeah, I will just message on LinkedIn. So next week definitely. The week after that also might be.
Okay. Yeah. Because I probably will ask some friends if they want to join, because I haven't informed anybody, but maybe I'll ask them now.
Yeah, I'm also doing another one session which is on power electronics. A lot of people showed up for that, like almost 25 people.
Even I am a part of that. Actually, I have. I know you because of Python Power Electronics.
Okay.
I have done your Udemy courses as well.
Okay, great.
So from there, I came to know about your work and all that.
Yeah. So that's another one that you are organizing, is it? But I think that was closed, right? That number of people is reached.
I don't know. I didn't put a limit, and as per this, I don't know how many people this API can support. So there might be a limit. There were some people who complained that it's become too slow for them, so it probably reached a limit. They had to drop off.
By the way, sir, I have some comments regarding how should we move forward. Maybe actually I am an electrical engineer. I am a power electronics engineer. So I am most focused on how to do the computational parts of the differential equations like we encounter in our typical power electronics applications, and developing our controller models, plant models from the state equations. So maybe if we could dedicate some sessions, 1 or 2 sessions on those things as well, then it will be beneficial for me personally, and also for non-electrical engineers also. They must be encountering somewhere such things like differential equations and all.
Yeah,
So
sure.
if
We
it's
can
possible,
even
then
do
we
that
can-
next time. Are you okay with it, Krishna?
Yeah.
Yeah, so we can solve a differential
okay.
equation. We can do a
So if
Runge-Kutta method.
if we could decide what specifically we should target, then maybe I could do some homework and I will be ready with something.
Oh yeah, sure. Just, I mean, like I said, it's like, see, it's like this. We can, if you can think of something, like for example, let's say you want to solve an resistive inductor circuit, right? Or something, whatever. See, like I said, it's not something that I'm an expert. I'm not an expert on everything either. If there is something we need to find out, we can find out together. That's also a part of the learning process, to be able to go and find out information. So like I said, this is a discussion group, not more of me teaching. It's more of us all getting together and learning.
I think, Krishnan, are you familiar with control systems and you use
He is a postdoc in control systems.
Yeah. But I mean, in fact,
actually, I'm not having what is the background, so that's why I'm asking you. So
I mean, my studies have always been in control systems. Yes, so I know.
Actually, I was
control
not
systems.
aware of what your background is. That's why I asked this question.
So both me and
maybe
Shiva both have a control background. Though Shiva has
I know many things about Shivakumar sir, but in your case, I don't know.
So
okay.
The control background is there, but for me, I haven't used Python to do a lot of the things that I normally do. So it will be a good idea for me to start. In fact, I have a proposition to do something with my friend who has asked me to see if I can help him in running some simulations and all that. So it will be a good idea to try something on these lines. So,
I think using sci-fi we can do all those things, na? Sir?
Yeah, I mean, there are lots of things we can do, but I mean, we can search. Like I said, we can code, we can search, we can do all those things. You are welcome to.
Okay, so then I will check. So Shiva, I don't know. You mentioned that Google Groups or anything, because I couldn't see anything from this.
Even I searched for that.
No, if you look, it's not there in the Howdy site. Just check. It should be, because if you go to Howdy, I'll just show you. If you just let me share my screen so that you know.
Yeah.
Oh, am I already sharing screen? No. Okay.
No. I was sharing.
Okay.
I stopped it.
Okay. So I'm just sharing screen. So can you see it? Yeah, should be. I'm going to groups and learn Python. Oh, I'm sorry. Okay, so I'll add it. It was I added it to simulation. Okay. So for example, it is here. You see forms that. So I'll just put it in the other one as well. So let me just do it right away.
Yeah. Do that, please. So what I would do is I'm just trying to see, because one of my friends suggested that he needed some help in simulating some I don't know, something to do with some bearing something. So essentially to simulate some differential equation, nonlinear differential equation, I think.
Basically, this is anything to do with like for engineers. That's all. It's like I don't want to do things
Actually,
like web development or something like that because that is very different. Though I'm a web developer also, but I don't want to start bringing that in. This is more for like actual core engineering purposes.
So in power electronics group, you're doing something else. Is it? It's mostly similar circuit simulator.
That is hardcore circuit simulation, yeah.
Okay.
And that's using the Python power electronics software. So
Yeah. That I see. Yeah. Does anybody use in academia? Have they published it with that?
not that I know of. No, not that I know.
Sir, actually, I am looking forward to publish a paper using your software. So, it means what are the anything like I need to acknowledge your site or your name?
No, you just usually whenever you write ups, whenever you in that thing, you just when simulation results are there, you usually write that, like for example, you would write I've simulated this using MATLAB or something. You just say Python. Power
Other than
electronics.
that,
No,
suppose
nothing.
in references your website will be mentioned and wherever a description will be there, that I will have to mention the software's name. So other than that, anything
No.
where I will have to give you acknowledgement and.
No, this is just a software. That's it.
Well, I think the book, if this book is there, you can just cite that book. That's
That is only if you're doing something in the actual simulator. I think if you just want to use it, you just have to mention Python power electronics. That's it.
Yeah, okay. Okay, so I was working on a model of a buck converter or boost converter. I was studying for past few days, so I have the equations ready. Then I think I will try to model it in Python using SciPy, and whatever I have, I will share the screen. I will share the screen, and then we will move forward.
That's good.
Okay.
That would be great.
Okay.
Yeah. Good. Okay, perfect.
Okay, that was great. It was a good session. I think much more, little more interactive than just me sharing and coding. So let's keep this up. Let's hope some few other people join. If you have any friends who would like to join, by all means, welcome.
I will share with my college friends.
Sure. And I will be recording and putting this up, so you can always watch later.
Yeah. Okay. Right. So you will share that on LinkedIn, right? Your links.
Links and also in the Google group, so you can just sign up for that, and that's also.
Yeah. Okay.
And by the way, Krishna, are you accessible in between? Because in this course of 1 week, if I need any help, because Shivkumar sir will be very busy, but if you are accessible, then may I contact you some way?
Yeah. You can contact me. So the only thing is this week and probably next week I'm going to be busy, simply because I have some exams.
Okay.
Yeah, but you can write to me because on Tuesday and Thursday I have some exams. Some French exams I'm giving, so it's a headache.
Okay.
But anyway, you can write to me if you want. You write to me. You just have to find out how to do that. You can check. I'm a friend of. I'm a connection of Shiva in LinkedIn. So if you are connected to him, you will be able to.
Yeah. I will.
Okay. Yeah, no problem.
Okay. Bye everyone. See you next time.
Bye.
Bye.